Hello, thank you for clicking on this video. Thank you for being curious enough to see what I have to say about the field of chemistry and the science of chemistry. You know, the more I shoot videos and the more I play with my video editing software, the more I'm learning and the more I'm starting to see all the different things you can do in terms of creating media and generating video content. So the video you are about to watch was shot a day or so ago. Actually, it was shot in parts. And when I was at work today, I realized that there was something I wanted to add on the end. So I created this little intro here to ask you to watch all the way through to the end, because there's something on the back there once you finish hearing about the periodic table and bonds and calculations and those kinds of things. So please watch through to the end. Okay, enjoy. Hello, and welcome back to Big Discussions. My name is Dr. Anwar Youssef Dunbar. I am the owner and the creator of this channel. I am also the owner and the creator of the Big Words blog site. The information for my blog and for all of my social media accounts are on the banner for this channel. Please subscribe to the blog or add the link to my RSS feed to your emails feed reader. I have a bunch of cool stuff that's up there already, and I have a bunch of cool stuff that I just published up today and this weekend, so please check that out. Today is June 8th, 2019, or today was. It's at nighttime, so the day is almost over. For this video, I want to continue my science series. So the first video in this series involved a discussion of the basic sciences and basic research, and I want to go into at some point what pharmacology and toxicology and inhalation toxicology and what ADME and drug metabolism are. And if the road goes on beyond those sciences, so be it. But I wanted to just kind of give a discussion of what those sciences are, because those are the sciences that I have been formally trained in. And also I think that there's a need in my community in particular. As I said in that video and other videos, when I meet other people who look like me in other professions, many of them say that I'm the first scientist that they've ever met. So that's the motivation behind using my channel to produce some of the science related content. So after my video on the basic sciences and basic research, someone over on Black Enough, which is a all-black platform created by Dr. Boyce Watkins, someone over there said they wanted to know a little bit more about chemistry, because I kind of touched everything on a high level: physics, chemistry, biology, and mathematics, because I wanted to introduce the STEMs. So this particular person, and this particular person has been an avid supporter of mine. I'll call her and shout her out. Her name is Miss Burdine, and I appreciate the support thus far. And so it's ever since she left that message, it's been in the back of my mind to come back and talk about chemistry a little bit. So that's why I'm here. And as you can see, today's t-shirt is of the periodic table of elements, which I'm going to talk about in this video. So please note that this video is for a general audience. So if you have a PhD in physical chemistry or analytical chemistry or organic chemistry or biochemistry, or if you have a very strong background in one of those fields, this will be very, very basic for you. So again, the rationale here is that there are whole communities in the United States where none of the people there know any scientists. So I'm hoping that this video might get in front of a youngster who has the ability to do science, but just doesn't know anyone in their ecosystem. And maybe if they watch some of this, they'll the light bulb will turn on, and they will say to themselves, okay, well, I want to do something like that as well. So that's the motivation behind this. And if you're again, if you have a real strong science background, just kind of bear with me here. And it's worth saying that, again, you know, less than 10% of STEM degree holders are black. So I think that's a huge statistic. Okay, so let's jump in. So chemistry. Let's talk a little bit more about chemistry. Chemistry is the study of our naturally occurring elements, their atoms, their physical properties. It's the study of how atoms bind to one another to create molecules and compounds. It's the study of the states of matter. It's the study of how numerous compounds and chemicals fit together and react together to form other compounds, other products. And it's a vast field which branches off into several other disciplines, which I'll discuss at the end of this video. The basis for chemistry is the periodic table of elements, which I'm going to show you right now. Okay, so what you just saw was a close-up of the periodic table of elements, and that was actually a close-up of my favorite periodic table of elements. I actually bought this a couple of years ago when I started tutoring, and over the years I've made some extra cash tutoring kids here in Northern Virginia in AP and IB chemistry, and I've gotten called back numerous times, so I think I'm a pretty good tutor. Anyway, so the periodic table, why is this important? It's the basis for chemistry, and it's kind of like a catalog of all of the known elements on our planet and in the our galaxy and the universe. And I'm going to come back to that later on in terms of outer space. But if you look at any periodic table, if you go horizontally from right to left, the elements are organized in groups. If you go vertically, the elements are grouped in terms of periods. So you have groups going horizontally and you have periods going vertically. If you notice, every element on the periodic table has a number, and that is its atomic number. Each element has an atomic number based upon the number of protons that are in its nucleus. Every element on the periodic table has an atomic mass. Every element on the periodic table has something called an electronegativity. Every element has an atomic radius. So the theory is that every element as an atom is basically a small circular structure with protons in the middle, protons and neutrons in the middle, and with electrons orbiting on the outside. The elements on the periodic table are they're grouped. So over towards the right side, those are for the most part metals. And then once you go into the center of the table, those are the transition metals, and they can hold multiple what we call oxidation states. And then as you go further to the left, there are the metalloids, and these have properties of metals and nonmetals. And then over on the left, you have the nonmetals. So you have stuff like carbon and nitrogen and oxygen and sulfur, and you have a group called the halogens, which consist of fluorine, chlorine, bromine, and iodine. And then on the far left you have the noble inert gases, which are pretty non-reactive. So, you know, and some of your metalloids are things like boron and silicon and germanium and arsenic and antimony, and you know, your transition metals are iron and cobalt and nickel and manganese and chromium, and so the periodic table is basically, it's a catalog or a list of all the elements on that we know or that are known, and the elements there are grouped in terms of their properties, their physical, chemical properties, and these elements, they react together based upon those properties. Some of them are very reactive, some of them are non-reactive, and that's based upon their, you know, atomic radii and their electronegativity and those kinds of things. So that's the periodic table of elements. So everything in chemistry ultimately goes back to the periodic table of elements, which you just saw, and I just gave a description of this. But I want to go back to my discussion about the actual atoms, which represent every element. And I stated that every element on this periodic table has an atomic number, but I didn't really talk about the atomic mass. Or maybe I did and I didn't explain it very clearly. But every element on here has an atomic number and it has an atomic mass. And you'll notice that the atomic number is different than the atomic mass. And basically that's because the atomic number actually designates the number of protons in the nucleus of the atom, while the atomic mass accounts for both the number of protons and neutrons in that nucleus. And so the neutrons, as the name implies, those don't have any charge, but they have mass. With the protons, they have charge and they have mass as well. And the electrons, which are believed to form a cloud around that nucleus, they have a negative charge, but they don't have a mass or a significant mass, because numerically they actually do, but it's negative it's a highly negative number, so it's very negligible. So that's the periodic table and the elements on the periodic table. Oh, one other thing. When I described it before, I left out the rare earth metals. And the rare earth metals are those right here at the bottom. And those are, promethium, uranium, that's a big one. Plutonium, that's a big one. And that's that group, and that's at the bottom of the table. So when I opened up this talk, I talked about how one of the concerns of chemistry is how the various elements and atoms fit together, and how numerous molecules and compounds fit together and react together. So let's look at some models. So someone, I think it was a former coworker, actually left me an old organic chemistry set, and it's been sitting in my cube forever at my job, and I never thought that I'd have a need for it, and it turns out I figured I could use it in making this video. So let's look at some models. So this, I don't know if you could see this, but this is a water molecule. The red represents an oxygen, and the two white spheres represent hydrogen. And I'm going to go into a little bit of biology here. This is the orientation of water. It's got this bent structure, and water has several properties that make it an ideal molecule for life, and it lies in its hydrogen bonding. And so basically, the hydrogens are covalently bound to the oxygen, which means that there's an equal sharing of the electrons here. But and so because of the properties of the oxygen and the water, there's a net negative charge around the oxygen, and there's a net positive charge around the hydrogens. And so when you look at a cup of water, or when you look at the ocean, you're seeing billions and billions and billions of water molecules fitting together like this, because the net negative oxygens are attracted to the net positive hydrogens. So one of the things that makes water conducive for life is that it's highly cohesive. So it packs well together, whether or not it's in the liquid form or it's in the solid form, in the form of ice. Because it packs together so well, it's got a high specific heat. So it takes you a while to warm up a pot of water so that it boils. And when it boils, these molecules go into the gas phase, and they boil off. One other property is that the water molecules are polar, and I just described that. One part has a net negative charge, and the other part has a net positive charge. And because these molecules are polar, it allows them to dissolve a lot of the ions that we need to live, such as sodium and potassium and chlorine. So water is a very important molecule. This right here is molecular oxygen. So once again, the red pieces here represent oxygen atoms, and diatomic oxygen is actually it actually has a double bond, and this is what we breathe in all the time, and our cells need this to live. This is ammonia. The blue piece represents a nitrogen atom, and once again the spherical pieces represent hydrogens. So this is NH3, and if we take this piece here and put this on here like this, this becomes ammonium, which is NH4. This one right here, this is ethanol. So this is in your wine, your beer, your liquor, your gin, your whiskey, whatever it is you like to drink. This is ethanol. And this is an organic molecule because it's got a carbon backbone, and a hydroxyl group here, which makes it an alcohol, an organic alcohol. And finally, this hydrocarbon right here, I believe the name of this one, I haven't taken organic chemistry in a while, but I believe the proper name for this is 1,2 hexene, based upon this double bond here. So 1,2 hexene. So this is an example of what we mean by when chemistry dealing with how different atoms and molecules, different atoms bind together, and different compounds and molecules reacting together. Because the atoms can come together and create something, and then you can have multiple molecules coming together in a reaction to create something else. So chemistry is a highly quantitative science, meaning that it's once you get past learning about the periodic table and the properties of the elements on the table, and how some of these atoms bind together, and how some of the molecules and reactants get together to form numerous products, you get into the very quantitative phase of the science. And you'll find that it's, in some respects, it's a lot like physics, and so you very much need one of these. And so once again, while the first part of chemistry involves learning about the periodic table, the elements, their properties, and how they all interact with one another, and how different atoms bind to each other, and how the different atoms and elements have different properties. Once you learn all that, you get into the highly quantitative phase. And right now I'm going to give you a feel for that by showing you what's on the back of my periodic table. So take a look. And so once again, while everything goes back to the periodic table of elements, and this reaches into pretty much every chapter, that previous set of snippets from the back of my table, I hope you're able to see that there are numerous laws, formulas, and constants, such as, for example, Avogadro's number, which is the unit which we use to calculate the number of molecules, and molecules are different than the number of moles. There's a standard concentration for an ideal gas at standard temperature pressure. There's water has a specific heat. There are the gas laws, which impact everything, such as in agriculture, fumigants, bioterrorism, and even commercial flight. We often think of chemistry in terms of mixing solutions which is what we often see on television, but numerous elements and compounds exist as gases in the air. And even for just the gas laws, which is one of my favorite units, there are several units of measure to manipulate and several calculations to know. And once again, everything goes back to the periodic table of elements. There are numerous reaction types, oxidation and reduction reactions, combustion reactions, synthesis reactions. There are reactions of all kinds. There are numerous subsections of chemistry. Just off the top of my head, biochemistry, organic chemistry. We just got a sample of that when I showed you those molecules. Physical chemistry, analytical chemistry, forensic chemistry. All of these areas, all of these branch out into numerous areas and to numerous careers and sectors such as agriculture, medicine, pharmaceuticals, biotech, energy, and aerospace, and astronomy. Going back to the periodic table, one of the ways that NASA is able to look at exoplanets and get an idea, one of the ways they're able to get an idea of whether or not those planets would be suitable for life, for us living on those planets, is that all of these elements, they have a signature radiance. So the telescopes that NASA sends up into the into outer space, they can look at the radiances or the luminescence of the various elements on these planets, which are light years away, and they can say, okay, well, there's iron over there, or there's oxygen over there, or there's carbon or nitrogen. So chemistry reaches into numerous industries and sectors. So I think I'm going to conclude there. This talk was for novices and for people who don't have any scientists in their ecosystems at home. And if this hits the right person, perhaps it'll start a discussion in that ecosystem, or maybe it will inspire some young person to say, okay, well, chemistry sounds cool, I'd like to get involved with that, and I'd like to explore that further. I think I didn't understand chemistry when I first took it in high school. That was in large part because I didn't understand how to focus on being a student, but I also didn't understand how all of the calculations and all of the principles went together. I just didn't understand how to put everything together. And yeah, the math can scare some students off and discourage them, but once you understand it and you understand what's going on, it actually becomes kind of cool and kind of fun, such as the gas laws, which I described a little while ago, and calculating molar concentrations and percent yields, theoretical yields, all those things, empirical formulas, all those things. So with that, I'm going to conclude. Chemistry is everywhere. It's in everything around us, and it's everywhere. I guess that's just the best way I could say it without further without thinking of further examples. So with that, I'm going to conclude this. I hope, Ms. Burdine, I hope this gave you a clearer understanding of what chemistry is. And if not, please leave a comment in the comment section or ask me. And with that, I will conclude this portion of my science series, and I have other topics I want to address and get into. But just from this video, just know that that's what chemistry is, and that it extends into pretty much every area of our lives, just like physics. So with that, I will conclude. I will sign off, and always remember that your attitude determines your altitude. Take care, and I'll talk to you next time. Oh, please like, share, and subscribe to the channel. Bye-bye. So if you enjoyed my introductory video to the science and the field of chemistry, I wanted to make or leave a few recommendations. I do ultimately plan to talk about pharmacology, toxicology, ADME / drug metabolism, and inhalation toxicology, and some other scientific topics. But if you can't wait until I shoot those videos, because other things are going to come up in the meantime, I'm leaving those blog posts in the description box below. I'm also going to leave my Black History Month write-up on Dr. Percy Julian, who was a legendary chemist, and for novices who are just entering the sciences or might have an interest in getting into the STEMs and particularly chemistry, Percy Julian's story is very, very powerful, and it's a story that I wish that I had learned before I started my own scientific journey. I'm also going to leave my interview with Dr. Vernon Morris, who is a collaborator and a friend at Howard University, and he's a chemist, and he's very passionate about getting science out to underserved communities. So that's what I wanted to say. Please look at the description box below if you want to read some more interesting stuff. Chemistry, again, it's a very versatile, and it's a very vast field, and it absolutely reaches into the biomedical sciences, which I was trained in: pharmacology, toxicology, ADME / drug metabolism, and inhalation toxicology. So with that, now I will conclude this video. Thank you for watching. Please like the video, please share it, and also please subscribe to my channel. I'll see you next time. Bye-bye.